So here is Chapter 2, Exercise 2.3, and this looked interesting because you know, when I first take a look at it here, and I'm doing these, you know, as I'm writing these down and reading them. I haven't done them before, and that's partly so you can see that sometimes I maybe get right to the point and can get an answer right away, but other times I might get a little blocked on something and I'll have to think about it. But in 2.3 we're doing this break-even analysis. Now typically I know that means, you know, when you finally become profitable or something like that. So a firm is considering the production of 2 new products. Data pertaining to sales price and costs are shown in the table. Okay, so we'll have to look at that table. The firm is already contracted to provide 500 units of product A and would like to calculate the break-even quantities for products A and B. Formulate an LP model to determine the break-even points for products A and B at minimal total capital outlay. Sounds like cost to me. Minimum total capital outlay. So what they want to do is minimize cost. But they would like to break even. Okay, so let's kind of look at the table and try to figure out what we have here. So we've got product A and B, and we've got our selling price, and that's 30 and 35. And then we have a variable cost per unit, so that means with every unit we have to spend that much. So variable cost is 16 and 18. And then a fixed cost, now see, this is interesting. Fixed cost is way up at $10,000 and $12,000. Well, we had to invest in land, factories, whatever, machines, that kind of thing, and so we have our fixed cost. So what I want to do is, I guess, minimize my cost. Okay, so I want to minimize my cost. So how do I get my cost? Well, that has nothing to do with the selling price. To minimize my cost, I know it's going to cost me $10,000 and $12,000 in the fixed prices. So I have minimize, and I'm going to put those over here. My 10,000 plus 12,000. Now, as it turns out, actually, I don't need to put those in, but and we'll get rid of them here in a minute. But let's keep them in because I'm thinking about cost. So cost, minimize cost. And then I guess if I didn't write it down, but if A is the number of units of product A and B is the number of units of product B, then my cost there would be 16 times A plus 18 times B plus the 10,000. Now I'm gonna maybe I'll do a whole video on this at some point, but let me add another page just as an aside and say, notice that what happens, you know, if I'm trying to minimize, you know, c1x1 plus c2x2, you know, plus just some other value k, that doesn't really matter. It's going to change the value of this thing, but it doesn't change the location. Now the reason it doesn't is, remember what we do is, you know, we're saying, oh, z equals, you know, c1 x1 plus c2x2 and then plus k here, you know, we're picking values of z and drawing parallel lines. Well, okay, move the k over here. Z minus k is equal to c1 x1 plus c2 x2, and you know, and I can rename z minus k just as anything. How about q? We hardly ever use a q there in a place like that, so we'll do that, right? So I still get all these parallel lines, usually that might look like that. So I still get all those parallel lines. They're just going to have a different value of z, but the line itself, its properties are the same. And so if I was going to hit at that point, I'm still going to hit at that point because these lines are still parallel. So it doesn't, you know, this adding or subtracting a number there doesn't matter as far as the actual finding of a and b in this case, or x and y in general, or x1, y, x1, x2, and so forth. Okay, so we want to minimize that cost. Now, subject to what? Well, we want to break even. And so, in order to break even, I have to sell the same amount as the cost, right? My revenue has to equal my cost. And so, to get revenue, I'm just going to take 30 times A, and then minus my cost, so minus 16A minus 10,000. Now here, the 10,000 matters, okay, because it's a constraint, and so that line is in a particular place. But up here, it doesn't. So we can, you know, we can just get rid of that and just minimize 16A plus 18B. Now, I have to look back at the problem, because here, you know, I'm looking at a break even for product A, but there's a question, do I want to break even overall? In other words, can I make money on A and lose money on B in order to minimize my cost? Or do I have to break even on both of them? And so I look back at the instructions, and it says, again, formulate an LP model to determine the break-even points, okay, plural, break-even points for products A and B at minimal total capital outlay or minimal cost. And so it appears they want break-even points for each product. And so this revenue minus cost needs to be at least 0. Now notice I didn't say equals 0, because what's wrong with it doing better than that? You know, if I still minimize cost, not a problem. And so I will do a greater than or equal, and then similarly 35B is the revenue there, minus 18B minus 12,000 has to also be greater than or equal to 0. So there are our break-evens, but now they also said that they've already contracted for 500A, so A needs to be greater than or equal to 500, but B simply needs to be greater than or equal to 0. They didn't say anything about B. And so if you have, you know, the constant in there, that's okay, but actually you don't need it. Okay, not in the objective function up here. So in the constraints, very important, you know, because I could move those over and I would have to say that amount needs to be greater than or equal to 10,000. Well, if I take that 10,000 out of there, that changes the constraint a lot. Okay, but up here, it doesn't change where A and B are going to be for this problem, because again, it doesn't do anything to the direction of the line that is being used. So it doesn't matter it will change that minimum cost. So a person might want to leave it in to find out, to remember to have it there for the minimum cost. But actually, they, in a way, they seem to be more interested in what the value of A and B are than what that cost is, just the way they stated it. But I would think you'd want to know both. Okay, so here is our model for exercise 3.